Hello, and a warm welcome to the Bedtime Lab, where we embark on a journey of discovery and relaxation. Tonight we'll be exploring the wondrous world of asteroids and cosmic impacts. Imagine yourself gently drifting in the vastness of space, surrounded by the silent, twinkling stars. It's quite a thought, isn't it? As you settle in for the evening, I want to create a cozy atmosphere, as if we're old friends sharing fascinating tales by the fireside. So, before we begin, I invite you to share where you're joining us from in the comments. It's always lovely to know where our fellow stargazers are tuning in from. Now, let me share something interesting. Did you know that asteroids are sometimes referred to as minor planets? These celestial bodies, remnants from the early formation of our solar system, hold secrets that stretch back billions of years to a time when the planets were still taking shape. Speaking of which, our solar system is home to millions of asteroids, most of which reside in the asteroid belt between Mars and Jupiter. Can you imagine how it must feel to be surrounded by such an ancient and endless dance of rocks and debris? Here's a fascinating fact. While we often picture asteroids as large, imposing objects, they can actually be quite small. Some are no bigger than a pebble, yet, despite their size, they hold immense power and potential for understanding our cosmic history. And did you know that the largest asteroid in our solar system is Ceres? It's about 940 kilometers in diameter, making it almost round like a planet. In fact, Ceres is so large that it's classified as a dwarf planet. This reminds me of something intriguing. Asteroids are composed of different materials, often characterized by their spectral types. For instance, some are rich in carbon, while others contain metals like nickel and iron. Imagine the diversity, each one a small, rocky world with its own unique composition and story to tell. And here's something you might find surprising. Although asteroids are rocky bodies, they can have moons of their own. Yes, some asteroids are accompanied by tiny satellites that orbit them, much like the Moon orbits Earth. Isn't it remarkable to think of these little cosmic companions quietly circling their asteroid hosts? Now, let's talk about cosmic impacts. These are not just the stuff of science fiction, but have played a crucial role in shaping our planet. For instance, the Chicxulub impact, which occurred around 60 to 6 million years ago, is believed to have caused the extinction of the dinosaurs. This impact left a crater over 180 kilometers wide in what is now the Yucatan Peninsula. The sheer scale of such an event is awe-inspiring, reminding us of the powerful forces at play in the universe. Speaking of impacts, did you know that Earth is constantly being bombarded by space debris? Thankfully, most of it burns up in our atmosphere as meteors, those beautiful streaks of light we sometimes see in the night sky. It's a comforting thought to know that our atmosphere acts as a shield, protecting us from potential harm. Here's another fascinating tidbit. In space, asteroids can sometimes collide with one another, creating a spectacular chain of events. These collisions can break asteroids into smaller pieces, some of which might be sent hurtling towards Earth. And yet, even though the thought of an asteroid impact might seem daunting, scientists around the world are constantly monitoring these space rocks, ensuring we stay informed and prepared. Did you know that every 20 to 25 years, Earth experiences an asteroid impact that releases energy equivalent to around a few kilotons of TNT? While this might sound alarming, these impacts are usually harmless, occurring over uninhabited areas or burning up in the atmosphere before reaching the ground. And here's something to ponder. There are missions currently underway to study asteroids up close. NASA's OSIRIS-REx mission, for example, traveled over 2 billion kilometers to reach the asteroid Bennu. This mission aims to collect and return samples, helping us unlock the secrets of the solar system's formation. It's like sending a robotic explorer to bring back a piece of the universe for us to study. Let me share another captivating thought. Some asteroids are considered potential sources of valuable resources, such as water and precious metals. The concept of asteroid mining, once a distant dream, is slowly becoming a possibility. It's fascinating to think that one day these rocky bodies might help sustain human life in space. As we continue our journey through the cosmos, I hope you're feeling a sense of wonder and curiosity about the universe we call home. Each asteroid and impact tells a story, a chapter in the grand tale of our solar system. As we settle into the rhythm of the night, let these stories lull you into a gentle, restful state, where dreams of the stars await. Did you know that some asteroids actually have their own atmospheres? These are known as exospheres, extremely thin layers of gas that can form around an asteroid. It's fascinating to imagine these small bodies having even a faint whisper of an atmosphere around them. Speaking of atmospheres, something remarkable is how these exospheres can be influenced by solar radiation and the asteroid's surface composition. As the sun's rays hit an asteroid, the surface can release particles into space, forming this delicate layer. Now, here's an intriguing thought. Asteroids can have a variety of shapes, often resembling anything but a sphere. Due to their small size and low gravity, they lack the force needed to pull themselves into a round shape. This gives them a range of forms, from elongated and irregular to dog bone-like shapes. Imagine these celestial objects, each with their own unique silhouette, drifting silently through space. And here's something quite surprising. The asteroid belt itself is not as densely packed as movies might have you believe. In fact, the asteroids are spread out over such a vast area that a spacecraft can travel through the belt with little risk of collision. Imagine a lone spacecraft navigating this immense region, where each asteroid is a tiny island in a vast cosmic ocean. Let me share something else that's fascinating. The term asteroid comes from the Greek word asteroides, which means star-like. It highlights how, in telescopes, these objects often appear as points of light similar to stars. This star-like appearance, however, belies their true nature as rocky bodies, each with its own secrets to uncover. Did you know that some scientists believe asteroids could have played a crucial role in the formation of life on Earth? It's thought that asteroids might have delivered essential compounds, such as water and organic materials, to our planet in its early days. Imagine these space travelers seeding the building blocks of life across the cosmos, sparking the diversity of life we see today. Another intriguing fact is that the famous Tunguska event of 1908 was likely caused by an asteroid or comet fragment exploding in the atmosphere over Siberia. This explosion flattened an estimated 2,000 square kilometers of forest, yet left no crater. It's a powerful reminder of the dynamic and sometimes unpredictable nature of our universe. Speaking of impacts, did you know that the Barringer crater in Arizona, also known as Meteor Crater, is one of the best preserved meteorite impact sites on Earth? This impressive crater is over 1 kilometer wide and nearly 200 meters deep, formed about 50,000 years ago by an impactor estimated to be just over 50 meters wide. Standing at the edge of such a site, it's easy to picture the dramatic event that created it. Here's a thought-provoking idea. Some asteroids are classified as potentially hazardous objects if they come within 7.5 million kilometers of Earth's orbit, and are large enough to cause significant damage. It's reassuring to know that astronomers keep a vigilant watch on these space rocks, ensuring we remain aware of any that might pose a threat. And did you know that the study of asteroids has led to some interesting technologies here on Earth? The techniques developed for tracking these objects have contributed to advancements in fields like satellite navigation and even medical imaging. It's amazing how our quest to understand the cosmos can have such practical benefits. Imagine this. Asteroids exist not only in our solar system, but also around other stars. These extrasolar asteroids, or planetesimals, are believed to be building blocks of other planetary systems. It's a humbling thought to consider that similar processes are happening throughout the galaxy, perhaps leading to the formation of worlds we have yet to discover. Speaking of discoveries, the Dawn spacecraft, which visited the asteroid Vesta and the dwarf planet Ceres, provided invaluable information about these bodies. For instance, it discovered that Vesta has a mountain twice the height of Mount Everest. Imagine standing at the base of such a colossal feature, towering above Vesta's surface. Here's a surprising tidbit. Some asteroids have surface features like troughs and ridges, hinting at their complex geological history. These features suggest that asteroids can experience tectonic-like activities caused by impacts or even the pressure of their own rotation. Each scar and groove adds a chapter to their story, waiting patiently for us to read. And while we often think of asteroids as solitary wanderers, some travel in pairs or even groups. These binary or multiple asteroid systems show that these objects can form around or stick together, creating miniature solar systems of their own. Imagine these clusters of rocks, bound by gravity, journeying together across the cosmos. Did you know that the largest known asteroid family, the Flora family, was formed by a colossal collision over 1 billion years ago? This family consists of hundreds of members, each one a fragment of that ancient event. It's a testament to the dynamic and ever-changing nature of our solar system, where even an impact can give birth to a new collection of celestial bodies. Imagine the possibilities if one day we harness the energy and resources of asteroids. They could provide the raw materials for space habitats, or fuel for journeys beyond our solar system. The stars are within reach, and with them the potential for endless exploration. As these stories unfold, they remind us of our place in the universe, and with each fact, we draw a little closer to the mystery and majesty of the cosmos. Let me share a curious fact about asteroids. Some of them are made almost entirely of metal. These metallic asteroids are thought to be remnants of ancient protoplanetary cores, suggesting they might offer us a glimpse into the early building blocks of planets. Imagine the possibility of standing on an asteroid composed mostly of iron and nickel, the same elements that make up the core of our own planet. Isn't it fascinating to think that these gleaming bodies could represent the missing chapters of our solar system's history? And here's something intriguing. Not all asteroids reside in the asteroid belt between Mars and Jupiter. Some, known as near-Earth objects or NEOs, have orbits that bring them close to our planet. These space rocks are of particular interest because they offer clues about the early solar system, and of course because of their proximity to Earth. It's like having a cosmic library right in our neighborhood, waiting to be explored. Speaking of exploration, did you know that asteroids can sometimes have moons of their own? These tiny satellites orbit their parent asteroid just as the moon orbits Earth. The discovery of these asteroid moons has been a delightful surprise for astronomers, prompting further studies into how such systems form. Imagine the gentle dance of these moonlets around their host, a celestial waltz in the silence of space. Let me tell you about a surprising endeavor. There are initiatives underway to mine asteroids for resources. These space mining ventures aim to extract valuable metals and water from asteroids to support future space missions. Imagine the innovation and technology that could emerge from such endeavors, potentially opening new chapters in human exploration and industry beyond our planet. Have you ever wondered about the colors of asteroids? They can range from gray to reddish-brown, depending on their composition. This variation in color provides key insights into their mineral makeup and the processes they have undergone. It's like piecing together a puzzle from the spectrum of light reflected from these distant objects, giving us clues about their origins and transformations. Here's a captivating thought. Some astronomers believe that asteroids may contain clues about the mystery of dark matter. While dark matter is not directly observable, the gravitational influence it exerts could potentially affect the distribution and behavior of asteroids. Imagine these rocky bodies as markers in a cosmic map, helping us trace the unseen forces shaping the universe. And did you know that the study of asteroid impacts has led to theories about mass extinctions on Earth? It's widely believed that an asteroid impact led to the extinction of the dinosaurs around 65 million years ago. This event, known as the Cretaceous-Paleogene extinction, highlights the profound influence asteroids can have on life, reminding us of the interconnectedness of celestial events and terrestrial history. Let me take you to the realm of cosmic impacts on other planets. The surface of Mercury, for instance, is heavily cratered due to constant bombardment by asteroids and comets. These impact craters offer a window into the planet's past, recording a history of collisions that have shaped its surface. Imagine standing on Mercury, surrounded by a landscape pockmarked with craters, each one a story of an ancient cosmic encounter. Here's something you might find fascinating. Asteroids can tell us about the distant past, but they also hold potential for the future. Scientists are developing techniques to deflect potentially hazardous asteroids, ensuring Earth safety. This planetary defense initiative is a testament to human ingenuity and determination as we face the challenges of living in a dynamic and ever-changing cosmos. Let me share another intriguing possibility. Some asteroids contain water in the form of ice, particularly those that dwell in the colder regions of the solar system. This water ice could be utilized to produce fuel or support life on future space missions. Imagine tapping into these icy reservoirs, unlocking new opportunities for sustaining human presence beyond Earth. And did you know that asteroids can have incredibly diverse sizes? They range from tiny pebbles to gigantic rocky bodies spanning hundreds of kilometers in diameter. This diversity in size reflects their varied origins and the dynamic processes that have shaped them over billions of years. Picture these cosmic travelers, each one unique in its journey and story, drifting through the endless expanse of space. Here's another mesmerizing thought. Asteroids can sometimes collide with each other, resulting in fragments that drift apart to form their own paths. These collisions can create smaller asteroid families, each with its own unique orbital characteristics. It's a reminder of the chaotic yet beautifully orchestrated dance of celestial objects throughout the solar system. What about the mesmerizing paths that asteroids take? Some follow elongated orbits that bring them close to the Sun before flinging them back into the depths of space. These long journeys can take millions of years to complete, a testament to the patience of the universe. Imagine tracing these orbital paths across the cosmos, each one a grand loop in the cosmic ballet. And finally, consider this: the potential for asteroids to be used as stepping stones to the stars. By utilizing their resources and strategic positions, humanity might one day establish bases on these rocky outposts, turning them into launch points for journeys to distant worlds. It's a vision of future exploration, where asteroids play a vital role in our quest to reach beyond the confines of Earth. As we continue to unravel their mysteries, we are reminded of the boundless possibilities that lie within the cosmos. Here's a fascinating concept. Not all asteroids are solid chunks of rock. Some are actually loose piles of rubble held together by their own gravity. These so-called rubble pile asteroids are like cosmic sandcastles, fragile and easily disrupted by impacts or gravitational forces. Imagine touching one carefully, feeling the individual rocks and dust held together in a delicate balance. The study of these asteroids provides insights into how materials behave in low-gravity environments, offering valuable lessons for future space missions. Speaking of gravity, did you know that some asteroids have very slight gravitational attractions, allowing them to capture small space debris? This phenomenon can lead to the formation of mini-moons or additional surface material, altering the asteroid's appearance over time. It's a bit like cosmic recycling, where the asteroid gathers and incorporates the remnants of its travels. Picture these small particles gently settling onto the asteroid's surface, slowly changing its landscape. And here's something intriguing. Certain asteroids have dusty tails, resembling the tails of comets. These dusty trails are often the result of the asteroid shedding material as it heats up near the Sun. It's a reminder of the dynamic relationship between asteroids and their environment, as these celestial bodies respond to the warmth of our star, casting off tiny particles in their wake. Imagine watching as the dust slowly drifts away, creating a temporary trail that sparkles in the sunlight. You might be surprised to learn that asteroids can sometimes have very peculiar shapes. Some are shaped like bones, dog biscuits, or even peanuts. These irregular forms are the result of their unique collisional history and gravitational interactions. Each asteroid's shape tells a story about the forces it has encountered, giving us clues about the chaotic environment of the early solar system. Imagine holding a model of one of these oddly shaped asteroids in your hand. Each curve and angle a testament to a long and tumultuous journey through space. Let me tell you about a curious phenomenon. Some asteroids spin so rapidly that their shape is altered, causing them to stretch out like a top. These fast-spinning asteroids have what scientists call equatorial bulges, as centrifugal forces push material outwards. It's a striking example of how motion can influence the physical characteristics of celestial objects, reshaping these ancient wanderers over time. Picture an asteroid spinning in the vastness of space, its surface slowly warping as it whirls through the void. Speaking of spinning, imagine this. Asteroids can sometimes be set into motion by the gentle pressure of sunlight. This effect, known as the Yarkovsky effect, occurs when an asteroid absorbs sunlight and re-emits it as heat, causing it to slowly drift and rotate. It's a subtle force, yet over millions of years, it can significantly alter an asteroid's orbit. Think of it as a cosmic nudge, where light itself is capable of steering these rocky travelers through the universe. And did you know that some asteroids have been found to contain organic molecules, which are the building blocks of life? These carbon-rich compounds suggest that asteroids may have played a role in delivering the ingredients necessary for life to Earth. It's an intriguing thought that these seemingly barren rocks could have been part of the story of life's origins, carrying essential components across the solar system. Imagine the possibilities hidden within these ancient pieces of cosmic history. Here's an interesting twist. Certain asteroids might have hidden caves or hollow spaces within them. These cavities could be the result of ancient impacts or internal processes, creating potential shelters for future explorers. Such natural formations could offer protection from cosmic radiation and extreme temperatures, aiding in long-term human survival in space. Picture stepping into one of these asteroid caves, a sanctuary carved into rock by the forces of the cosmos. Another captivating fact is that some asteroids have shown signs of geological activity, such as landslides or shifts in their surface material. This activity can be triggered by impacts or the asteroid's own rotation, hinting at a dynamic and ever-changing surface. Imagine standing on one of these asteroids, witnessing the gentle movement of rocks and dust as they settle into new configurations, reflecting the ongoing dance of the cosmos. Consider this enchanting possibility. Asteroids could potentially be used as a habitat for plants in space. By using their soil-like surface material, scientists are exploring the feasibility of growing plants on asteroids to support space missions. It's a vision of turning these rocky bodies into gardens among the stars, where life could take root in the most unexpected places. Imagine a small patch of green thriving on an asteroid, a vibrant testament to human ingenuity and adaptability. Speaking of life, did you know that asteroids can act as cosmic time capsules? Trapped within them are clues about the conditions of the early solar system, preserved for billions of years. These ancient records remain untouched by the passage of time, waiting for us to unlock their secrets. Imagine sifting through the layers of an asteroid, uncovering the whispers of a primordial era preserved in stone. And here's a final thought. Asteroids have been the inspiration for numerous myths and legends throughout history. Many cultures saw them as omens or messages from the gods, reflecting humanity's long-standing fascination with these celestial wanderers. It's a reminder of the deep connection between the cosmos and our imagination as we continue to seek understanding and meaning in the stars above. As we explore these mesmerizing facts, let yourself drift into a world of wonder, contemplating the infinite possibilities and stories that asteroids hold, each one a chapter in the grand tale of the universe. Imagine for a moment the impact that these celestial bodies have had on the Earth throughout history. Did you know that a significant portion of the water on our planet might have been delivered by asteroids? These water-bearing asteroids, known as carbonaceous chondrites, could have bombarded the young Earth, bringing with them the precious liquid that would eventually fill our oceans. It's a humbling thought to consider that the very essence of life as we know it might owe its existence to these ancient messengers from the cosmos. Now, let me share something that truly sparks the imagination. Some asteroids possess their own moons, orbiting around them like tiny companions on a cosmic journey. These moons, sometimes called satellites, can offer unique insight into the gravitational interactions and history of their parent asteroids. Imagine a tiny moonlet circling a much larger asteroid, a graceful dance through the void that has been ongoing for millennia. Speaking of fascinating partnerships, there's an incredible phenomenon known as binary asteroids. These are two asteroids that orbit a common center of mass, bound together by gravity. Picture two rocky bodies locked in a perpetual embrace, spinning around each other like cosmic dancers in an endless waltz. It's a mesmerizing reminder of the intricate balance and harmony that can be found even in the vastness of space. You might find it intriguing to learn about the asteroid belt, a vast region filled with countless rocky bodies between the orbits of Mars and Jupiter. This expansive zone acts as a kind of cosmic graveyard, where remnants from the solar system's formation still drift. These asteroids were once part of a planet that never was, its potential thwarted by Jupiter's immense gravitational pull. Instead, they remain as silent witnesses to the solar system's turbulent past, each one a fragment of a larger story. Adding to their enigmatic nature, some asteroids are found to be composed of metal, primarily iron and nickel, making them akin to the cores of planets. These metallic asteroids might be remnants of protoplanets that were shattered during the solar system's chaotic early days. Imagine mining these iron-rich bodies, providing a resource that could support future interplanetary travel and colonization. It's a striking vision of how humanity might one day turn space into a new frontier of exploration and utilization. On the topic of exploration, did you know that we have successfully landed spacecraft on asteroids to study them up close? Missions like NASA's OSIRIS-REx and Japan's Hayabusa have gathered samples from the surface of asteroids, bringing back invaluable insights about their composition and history. Think about the incredible journey these spacecraft undertook, traveling millions of kilometers through space to touch down on a moving target, all in the quest for knowledge. Here's a thought-provoking fact. Some researchers believe that studying asteroids could help us learn more about the potential for mining in space. The rare metals and minerals found on these rocky bodies could become a resource for future technologies and industries. Imagine a time when space mining becomes a reality, unlocking the wealth of the cosmos to fuel humanity's ambitions among the stars. The shadows that asteroids cast hold secrets as well. As they pass in front of distant stars, they cause a temporary dip in the star's brightness, a phenomenon known as an occultation. By observing these events, astronomers can determine the asteroid's size and shape with incredible precision. It's as if these celestial bodies are momentarily stepping into the spotlight, allowing us a fleeting glimpse of their mysterious forms. Let's consider another aspect of their mysterious nature: the possibility of asteroids hiding beneath the surface of their larger neighbors, like the Moon or Mars. These hidden asteroids might have been captured by the gravitational pull of these bodies long ago, becoming buried under layers of dust and rock. The idea of uncovering ancient asteroids on the Moon or Mars is like stumbling upon a cosmic treasure trove, waiting to reveal its long-lost secrets. Did you know that asteroids can sometimes be pulled into Earth's orbit, becoming temporary satellites? These are called mini-moons, and they offer a fascinating opportunity to study these objects up close. Imagine a small asteroid gracefully looping around our planet, a fleeting visitor in the grand theater of space. It's a reminder of the dynamic and ever-changing nature of our cosmic neighborhood. Reflecting on cosmic impacts, it's intriguing to realize that these events have shaped not only Earth's landscape, but also its biological history. The most famous of these impacts is the one that led to the extinction of the dinosaurs, paving the way for mammals to rise and eventually for humans to emerge. Think about the profound influence that a single asteroid impact has had on the course of life on Earth, a pivotal moment in the planet's evolutionary saga. And here's one more captivating thought to ponder: the possibility of using asteroids as stepping stones to travel further into the solar system. By establishing bases on these celestial bodies, we could create outposts that provide resources and shelter for astronauts venturing into deeper space. Picture a network of asteroid way stations, each one a beacon guiding humanity on its journey beyond the familiar. As the night deepens and you drift further into a state of wonder, reflect on the astonishing impact these rocky wanderers have had not just on Earth, but on the entire solar system. Each asteroid, with its unique story and potential, adds a new layer to our understanding of the cosmos, painting a picture of a universe filled with boundless possibilities and endless discoveries waiting to be made. Let me share something intriguing with you. Some asteroids have their own moons. Can you imagine that? These celestial bodies, which are relatively small, still manage to exert enough gravitational pull to capture a tiny companion. It's like a cosmic dance, where a smaller asteroid becomes a satellite, orbiting its larger partner in a gentle cosmic ballet. Speaking of which, did you know that certain asteroids are shaped more like potatoes than perfect spheres? Their irregular shapes are a result of countless collisions in the harsh conditions of space, eroding and reshaping them over billions of years. This quirky characteristic gives each asteroid a unique personality, a rugged charm in the vast expanse of the universe. Here's a fascinating fact. While most people think of asteroids as being rocky, some are actually covered in a layer of dust. This dusty mantle can obscure the surface and make it tricky for telescopes to accurately assess their composition. It's as if these asteroids are wearing a veil, concealing their true nature beneath a thin, wispy shroud. And reflecting on their complexity, consider the phenomenon of rubble pile asteroids. These are not solid bodies, but rather loose collections of rocks and dust held together by gravity. Imagine a giant cosmic heap of debris floating through space, its components gently jostling and shifting over time. You might find it surprising that the asteroid belt is not as densely packed as often depicted in science fiction. In reality, the vast majority of the belt is empty space, with asteroids scattered over millions of kilometers. So, a spacecraft traveling through this region is unlikely to encounter the dramatic, obstacle-filled journey we so often imagine. Yet, the variety of asteroids within this belt is truly astonishing, with sizes ranging from tiny pebbles to massive bodies hundreds of kilometers across. Let's delve into the fascinating topic of Trojan asteroids. These unique objects share an orbit with a larger planet, such as Jupiter, but maintain stable points ahead of or behind the planet as it orbits the Sun. It's as though these asteroids are cosmic hitchhikers, keeping pace with their planetary host, sharing a path through the solar system. And speaking of shared paths, did you know that some asteroids are classified as potentially hazardous? These are asteroids whose orbits bring them uncomfortably close to Earth, creating the possibility of future impacts. It's a reminder of how dynamic and interconnected our cosmic environment truly is. Another intriguing aspect of asteroids is their role in delivering water and organic materials to Earth. Some scientists theorize that during the early days of the solar system, icy asteroids and comets bombarded our planet, providing the building blocks for life. Imagine these celestial bodies as cosmic couriers, bringing essential ingredients to a young Earth, setting the stage for the complex life forms that would eventually emerge. This connection between space and life is truly profound, highlighting the delicate interplay between our planet and the universe beyond. On a slightly different note, consider the fact that some asteroids are found far beyond the main asteroid belt. These are known as near-Earth asteroids, and their orbits bring them close to our planet. They offer a unique opportunity for study and exploration, serving as accessible stepping stones for future space missions. Picture these asteroids as a bridge between Earth and the far reaches of the solar system, each one a potential waypoint on humanity's cosmic journey. In terms of exploration, Did you know that some asteroids have been found to contain amino acids? These are the building blocks of proteins and are crucial to life as we know it. The discovery of such complex organic molecules on asteroids suggests that the basic ingredients for life might be more common in the universe than we ever imagined. It's a tantalizing possibility, hinting at the potential for life beyond Earth, seeded by the very asteroids we study. Lastly, let me leave you with the thought of cosmic impacts as agents of transformation. While often viewed as destructive, these events can also create new habitats and opportunities for life. For example, the impact that ended the reign of the dinosaurs also allowed mammals to flourish, eventually leading to the rise of humans. Each impact, while catastrophic, also resets the stage, allowing for new chapters in the story of life on Earth. As you continue to ponder the vastness of space and the small yet significant role asteroids play within it, let your imagination wander. Each fact we've explored is a piece of the cosmic puzzle, a glimpse into the mysteries that our universe holds. As you drift into a restful state, consider the boundless wonders that await discovery and the endless possibilities that these celestial wanderers represent. Imagine a universe where asteroids are more than just solitary travelers. Let me share something fascinating with you. Some asteroids contain small pockets of frozen water. It's intriguing to think that these seemingly barren rocks might hold reservoirs of one of life's most essential ingredients. And isn't it amazing to consider that this water might have been preserved for billions of years, untouched by the passage of time? This ice could offer clues about the conditions of our solar system in its infancy. Here's an astonishing fact. Certain asteroids have been found to spin so rapidly that they defy typical expectations of stability. These fast-spinning asteroids, called superfast rotators, complete a full rotation in a matter of minutes. Imagine the sheer velocity required for these celestial objects to maintain such a brisk pace, balanced on the edge of centrifugal forces tearing them apart. It's a wondrous reminder of the dynamic forces at play in the cosmos. Did you know that some asteroids harbor metallic cores? These rare metal-rich asteroids can contain iron, nickel, and even precious metals such as gold and platinum. Fascinatingly, their composition hints at an origin story where they may have been part of a larger planetary body that was destroyed long ago. Each metallic asteroid is like a time capsule, offering a glimpse into the processes that shaped our early solar system. Speaking of ancient history, consider the fact that the Earth is regularly bombarded by tiny asteroids and meteoroids, most of which burn up harmlessly in our atmosphere. Every day, Earth is showered with tons of these small cosmic particles, creating shooting stars that dance across the night sky. It's a gentle reminder of our planet's constant interaction with the wider universe, a celestial spectacle that unfolds above us, often without notice. And here's something to ponder. Some asteroids are rich in carbon, a fundamental element for life. These carbonaceous asteroids likely contain organic compounds similar to those required for the beginnings of life on Earth. Imagine these spacefaring objects as cosmic laboratories, carrying the potential ingredients for life across the vast stretches of space. Their journeys may have spanned millions of years and countless kilometers, a testament to the interconnectedness of the cosmos. Interestingly, certain asteroids exhibit a phenomenon known as Yorp effect, where sunlight can actually change their spin rate and even alter their orbits over time. This effect occurs because the heat absorbed from the sun is re-emitted as thermal radiation, creating a small but measurable force. It's captivating to think that something as gentle as sunlight can have such a profound impact on these distant objects, subtly shaping their paths through the universe. Delving deeper, did you know that some asteroids have complex craters on their surfaces, evidence of past collisions and impacts? These craters tell stories of violent encounters and survival, each one a scar from battles fought in the silent void of space. The craters vary in size and shape, and through careful study, scientists can uncover the history and age of these celestial bodies. On a more delicate note, consider asteroids that exhibit a phenomenon known as regolith. This is a layer of loose, fragmented material that covers their surfaces, similar to soil on Earth. Regolith can vary greatly in texture and composition, depending on the asteroid's size, age, and location. It's intriguing to think that a dusty, rocky surface could reveal so much about an asteroid's journey through the cosmos. Did you know that some asteroids have complex orbits that take them beyond the traditional asteroid belt? These objects, often referred to as trans-Neptunian objects, are situated in regions of space that are still shrouded in mystery. Their paths take them into the distant reaches of our solar system, offering tantalizing clues about what lies beyond the familiar planets. As we traverse this cosmic landscape, imagine the potential for future generations to mine asteroids for valuable resources. The idea might sound like science fiction, but it's a growing field of interest for scientists and entrepreneurs alike. Picture a future where humanity reaches out to these spacefaring objects, not only for their scientific value, but also as a source of metals and minerals that could sustain our technological progress. Here's a thought-provoking aspect. When an asteroid impacts a planetary body, it can create a unique geological signature. The immense pressure and heat generated by the impact can transform minerals, forging new forms that are absent elsewhere. These impact signatures offer a window into the forces unleashed during such events, providing insights into the processes that shaped planets and moons. And speaking of transformation, did you know that some asteroids are linked to the formation of meteor showers on Earth? When a comet or asteroid enters Earth's atmosphere and breaks apart, it can leave behind a trail of debris. As our planet passes through this debris field, the particles burn up, creating spectacular meteor showers that light up the night sky. It's as if the universe is orchestrating a cosmic light show, inviting us to participate in its wonders. Finally, let's consider the role of asteroids in planetary defense strategies. Scientists are actively studying ways to prevent potentially hazardous asteroids from colliding with Earth. This includes developing techniques to nudge their orbits, diverting them from a collision course. It's a testament to human ingenuity and our desire to protect our planet from the dynamic forces beyond our world. As you drift deeper into thoughts of the universe, let these unexpected facts about asteroids nurture your sense of wonder. Each one is a reminder of the extraordinary complexity and beauty that lies within and beyond our cosmic neighborhood. Imagine for a moment the possibilities when an asteroid travels through space at blistering speeds. Some of these celestial travelers can reach speeds of up to 25 kilometers per second. That's nearly 3,000 times faster than a commercial airplane. This incredible velocity is a reminder of the sheer energy that accompanies these objects as they journey through the cosmos. Speaking of impressive feats, did you know that asteroids can have their own moons? These are known as binary or even triple systems, where a smaller asteroid orbits a larger one. It's a fascinating dynamic, akin to a miniature solar system in the making, with gravitational forces holding these celestial bodies in a delicate balance. Here's another captivating thought. Asteroids can exhibit distinct colors depending on their mineral compositions. Some glisten in shades of red, others in blue or gray, each hue telling a story of its formation and history. It's as if the universe has painted each asteroid with its own unique palette, a visual testament to the diversity of materials that make up our solar system. And consider this. Some asteroids have been found to contain water, either in the form of ice or bound within minerals. This discovery fuels the intriguing possibility that asteroids may have played a role in delivering water to early Earth, contributing to the conditions necessary for life. Turning our gaze skyward, let's ponder the phenomenon known as catastrophism. This is the idea that sudden, short-lived violent events, such as asteroid impacts, have significantly shaped the geological and biological history of our planet. The extinction of the dinosaurs, for instance, is widely believed to have been triggered by a massive asteroid impact. Imagine the impact of such events on the course of evolution, forever altering the tapestry of life on Earth. Speaking of life-altering events, some asteroids are classified as near-Earth objects, meaning their orbits bring them close to our planet. These asteroids are closely monitored by scientists as they hold the potential to impact Earth and influence its future. Here's an astonishing fact. The surfaces of some asteroids can reach temperatures as high as 400 degrees Celsius when facing the Sun, yet drop to nearly minus 100 degrees Celsius when in shadow. This extreme temperature variation highlights the harsh and unforgiving environment of space, where conditions can change dramatically with the position of the Sun. On the topic of extremes, did you know that the largest asteroid in our solar system is Ceres, located in the asteroid belt between Mars and Jupiter? Ceres is so massive that it comprises nearly 1/3 of the entire mass of the asteroid belt. It's a giant among asteroids, earning it the designation of a dwarf planet. Reflecting on the vast distances these space rocks travel, consider this. Some asteroids are believed to have originated from other star systems, making them interstellar visitors. These rogue asteroids, having been ejected from their original systems, wander through the galaxy and sometimes pass through our solar system. It's a humbling thought, isn't it? The idea that these ancient travelers could carry with them secrets from distant worlds. And speaking of secrets, scientists have discovered that some asteroids contain amino acids, the building blocks of proteins. This discovery suggests that the essential components of life might not be unique to Earth, but rather widespread throughout the cosmos. Have you ever wondered how scientists study asteroids up close? It's through robotic missions like NASA's OSIRIS-REx, which traveled to Bennu, a near-Earth asteroid, to collect samples and bring them back to Earth. These missions are groundbreaking, offering first-hand insights into the composition and history of asteroids, and are crucial for understanding the role these objects play in our solar system. Imagine the wealth of knowledge contained in just a handful of asteroid dust, a cosmic time capsule returned to Earth. In the grand tapestry of space exploration, asteroids offer a glimpse of the past and potential for the future. With each discovery, our understanding of these mysterious objects deepens, enriching the narrative of our universe. As you continue to ponder these celestial wonders, let your imagination wander across the vast expanse, tracing the paths of asteroids as they dance through the cosmos, each with a story to tell and a secret to reveal. It's truly amazing to think about the sheer diversity of shapes that asteroids can take. Unlike planets, which tend to be spherical due to gravity pulling matter equally from all directions, asteroids can be irregular, resembling anything from a potato to a dog bone. This irregularity is largely due to their smaller size and weaker gravitational force, which doesn't exert enough pressure to mold them into a spherical form. Can you picture an asteroid shaped like a giant peanut hurtling through space? Here's something curious. Some asteroids are hollow, or at least partially so. These rubble pile asteroids, as they're often referred to, are essentially loose collections of rocks held together by their own gravity. They are not solid bodies like planets or moons. Imagine them as cosmic sandcastles, where the brains are much larger and float through the void. Did you know that asteroids hold a wealth of metals, including gold, platinum, and iron? Some asteroids are so rich in these materials that they could potentially provide significant resources for humanity in the future. It's fascinating to think that one day we might mine asteroids, extracting these precious metals to use here on Earth, or in our ventures deeper into the cosmos. Speaking of the future, there's a concept known as asteroid redirection, where scientists propose altering the path of an asteroid to harness its resources or to prevent a collision with Earth. This isn't just science fiction, it's a serious topic of study and innovation. Imagine the ingenuity required to nudge an asteroid, much like directing a massive cosmic billiard ball across space. Have you ever heard of the Yarkovsky effect? It's a subtle force that occurs when an asteroid absorbs sunlight and then re-emits it as heat, causing a small thrust. Over time, this can alter the asteroid's trajectory. It's a tiny but fascinating reminder of how even the most delicate forces can influence the paths of these massive objects over millions of years. Then, there's the phenomenon of asteroid families. When a larger asteroid is shattered by a collision, it can create a group of smaller asteroids that share similar orbits. These families drift through space together like celestial siblings, their shared origin linking them across the vast expanses of the solar system. Here's a surprising thought. The asteroid belt is not as densely packed as you might imagine from movies. While it contains millions of asteroids, they are spread out over a vast area, so much so that spacecraft can travel through it without much risk of collision. In reality, the gaps between asteroids are vast, giving them plenty of room to maneuver. And here's a fact that might surprise you. The discovery of asteroids dates back to the early 19th century. The first asteroid, Sirius, was discovered in 1801 by Italian astronomer Giuseppe Piazzi. This marked the beginning of our deeper exploration into these space rocks, which were initially thought to be planets. The impact of an asteroid can release energy equivalent to thousands of nuclear bombs. The infamous Tunguska event of 1908, which flattened 2,000 square kilometers of Siberian forest, is believed to have been caused by an asteroid or comet fragment exploding in the atmosphere. Imagine the power of such an explosion, altering landscapes in the blink of an eye. Another captivating aspect of asteroids is their potential to harbor life. Some scientists speculate that microbial life could hitch a ride on asteroids, traveling vast distances through space. This idea, known as panspermia, suggests that life on Earth might have originated from such a cosmic journey. It's a humbling notion, contemplating that life as we know it could have been seeded by these celestial wanderers. Did you know that the term asteroid means star-like? When these objects were first observed through telescopes, they appeared as small points of light, much like stars. This star-like appearance is what inspired their name, even though they are very different from stars in composition and nature. Some asteroids have very eccentric orbits, taking them on long journeys far from their original locations. These erratic paths can be influenced by the gravitational pull of planets, which can alter an asteroid's trajectory dramatically. It's like a cosmic dance, with asteroids shifting partners as they pass near larger celestial bodies. Imagine an asteroid that rotates so quickly that it changes shape. Some asteroids spin at such high speeds that they can literally shift their forms, elongating or flattening as they rotate. It's a dynamic process, one that showcases the flexibility and diversity of these space rocks. Speaking of rotations, did you know that some asteroids have incredibly long days? For instance, the asteroid Gaspra has a rotation period of about 7 hours, much longer than Earth's 24-hour day. This slow spin offers a different perspective on time, reminding us of the diverse rhythms that exist throughout our solar system. And finally, consider the impact craters left behind by asteroid collisions, which can be seen on many planets and moons. These craters are more than just scars. They are windows into the past, preserving clues about the history of our solar system. Each crater tells a story of a collision, a moment when the universe's forces collided to shape the surfaces of worlds. As you let these thoughts settle, imagine the stories contained within each rocky body, waiting to be uncovered and understood. Let me share something intriguing with you. Did you know that some asteroids have moons of their own? Yes, in the vastness of space, an asteroid can capture a smaller object, creating a moon that orbits around it. This is especially fascinating when you consider how these miniature celestial systems mimic larger ones like our Earth and Moon. One well-known example is the asteroid Ida, which has a tiny moon named Dactyl. It's a beautiful reminder of how celestial mechanics work on all scales, from the grand to the minuscule. Here's a curious thought. Not all asteroids are rocky. Some are made primarily of metal, and others are composed of carbon-rich materials. This diversity stems from the different regions of the solar system where they formed. Metal-rich asteroids, for example, are believed to be remnants of the cores of ancient protoplanets that were shattered long ago. Imagine holding a fragment of a once mighty planetary body, now reduced to a wandering relic of the past. Speaking of wandering, have you ever imagined what it might be like to stand on an asteroid? The gravity on these small bodies is so weak that a gentle leap could send you floating off into space. This low-gravity environment presents unique challenges and opportunities. For instance, if we ever mine asteroids, we'll need specialized equipment to keep tools and machinery anchored firmly to the surface. It's a mind-boggling scenario, contemplating the logistics of working in such an alien environment. And here's something to ponder. Some asteroids have been found to contain water, primarily in the form of ice. This discovery has profound implications for the future of space exploration. Water is essential for life and can be broken down into hydrogen and oxygen, providing fuel for spacecraft. The presence of water ice on asteroids could make them crucial pit stops, supporting long-duration missions to the outer solar system and beyond. Did you know that asteroids can tell us about the history of our solar system? Many asteroids are considered primitive bodies, meaning they have remained largely unchanged since their formation over 4 billion years ago. By studying them, scientists can learn about the conditions and processes that existed in the early solar system. These ancient space rocks are like time capsules, preserving secrets of a time long before Earth and its neighboring planets took shape. Here's an interesting transition. While asteroids roam silently through space, they can create quite a spectacle when they interact with a planet's atmosphere. When an asteroid enters Earth's atmosphere, it becomes a meteor. Most meteors burn up before reaching the ground, creating a brilliant streak of light, known as a shooting star. However, if a fragment survives the fiery descent and lands, it becomes a meteorite. These meteorites provide direct samples of asteroidal material, bringing pieces of the cosmos to our doorstep. Have you ever wondered about the largest asteroid in our solar system? That title goes to Ceres, which is so large it's classified as a dwarf planet. Ceres resides in the asteroid belt between Mars and Jupiter and holds about a third of the belt's total mass. It's a fascinating world in its own right, with evidence suggesting the presence of an ancient ocean beneath its icy crust. Imagine the possibilities of discovering an ocean world hidden within an asteroid belt. Here's a surprising fact. The impact that led to the extinction of the dinosaurs was caused by an asteroid. Approximately 66 million years ago, an asteroid about 10 kilometers wide struck what is now the Yucatan Peninsula, creating the Chicxulub crater. This catastrophic event released energy equivalent to billions of nuclear bombs and had profound effects on Earth's climate and ecosystems, leading to the extinction of 75% of all species. It's a humbling reminder of the power these celestial bodies can wield. Moving to another fascinating topic, did you know that some asteroids are not alone in their orbits? There are binary asteroids, pairs of asteroids that orbit each other while traveling around the Sun. These cosmic duos offer unique insights into the gravitational interactions that can occur in space. By studying their orbits and rotations, scientists can gain a deeper understanding of the forces that shape our solar system. Imagine a future where asteroids serve as stepping stones for humanity's expansion into space. Some scientists envision a network of asteroid outposts where we could establish research stations and mining operations. These celestial waypoints could support our journeys to Mars and beyond, providing essential resources and a place to rest and refuel. It's a vision of the future where asteroids play a crucial role in our exploration of the cosmos. Here's something truly remarkable. Astronomers have discovered asteroids composed of materials that hint at volcanic activity. These asteroids, known as vestoids, are thought to have originated from the asteroid Vesta, which shows evidence of past volcanism. This discovery suggests that volcanic processes were not limited to planets and moons, but also occurred on smaller bodies in our solar system's history. And finally, consider the possibility of asteroid impacts shaping planetary evolution. While devastating in the short term, these impacts can also deliver essential materials, such as water and organic compounds, potentially influencing the development of life. It's a thought-provoking idea, considering how the violent interactions between these space rocks and planets could set the stage for life's emergence and evolution. Each impact, each fragment of rock and ice, contributes to the grand narrative of the cosmos, where chaos and creation are inextricably linked. Imagine, if you will, a world where diamonds fall from the sky. It sounds like something out of a fantasy, but some scientists theorize that carbon-rich asteroids could contain diamonds formed under high-pressure conditions in space. If these asteroids collide with Earth, they might bring these shimmering treasures with them. Now picture this. In the far reaches of our solar system, there are asteroids coated with dark, carbon-rich materials, making them some of the darkest objects known. These asteroids absorb most of the sunlight that hits them, making them appear almost invisible against the blackness of space. It's a bit like camouflaging themselves amidst the vast cosmic expanse. Speaking of cosmic wonders, did you know that there are asteroids with their own moons? Some asteroids are accompanied by smaller asteroid companions orbiting them, just like miniature solar systems. These moon-like bodies can provide valuable information about the gravitational dynamics in space. One particularly intriguing case is the asteroid Ida, which has a moon named Dactyl. Imagine the delicate dance between these two celestial objects as they journey together through the solar system. Here's a thought-provoking question for you. Have you ever considered the possibility of asteroids being mistaken for comets? Occasionally, asteroids exhibit comet-like behaviors, such as developing tails or comas when they come close to the Sun. These so-called active asteroids challenge our understanding of the differences between these two types of celestial bodies. It raises the question of whether some asteroids might harbor volatile materials beneath their surfaces, which sublimate and create these temporary comet-like features. Let me share something particularly fascinating. The study of asteroid craters on Earth has revealed much about our planet's geological history. Craters like the Barringer crater in Arizona provide a window into past cosmic impacts and their effects on Earth's surface. These scars of space collisions help scientists estimate the frequency and potential consequences of future impacts. Imagine standing at the edge of one of these massive craters, contemplating the immense force required to create such a feature. Surprisingly, not all asteroid impacts result in destruction. In fact, some impacts have been linked to bursts of life. The elevated temperatures and pressures from an impact can create environments conducive to the formation of complex organic molecules. It's a reminder of the dual nature of these cosmic encounters. While they can bring devastation, they might also set the stage for new beginnings. Did you ever wonder about the role of asteroids in the universe's chemistry? Asteroids are considered key players in the distribution of organic compounds and water throughout the solar system. When asteroids collide with planets, they can deliver essential ingredients for life, such as amino acids and other organic molecules. This celestial delivery service might have been crucial in seeding the early Earth with the building blocks of life. Consider this. Some scientists are exploring the potential of using asteroids as natural shields against cosmic radiation in space. When traveling to distant worlds, astronauts could benefit from the protective mass of an asteroid, which would block harmful radiation. This innovative idea could make long-duration space missions safer and more feasible, using the very objects we once feared as tools for survival. And here's something truly extraordinary. Our understanding of asteroids is constantly evolving thanks to robotic missions. The Hayabusa and OSIRIS-REx missions, for example, have provided unprecedented insights into asteroid composition and structure. These spacecraft have even returned samples from asteroids, allowing scientists to study them in detail here on Earth. It's as if we're catching glimpses of these ancient wanderers up close, piecing together the mysteries of their origins. While we're on the subject of exploration, did you know that asteroids have been proposed as potential sites for future space habitats? The idea involves hollowing out large asteroids to create livable spaces within them. This ambitious vision imagines a future where humanity expands its presence into the asteroid belt, tapping into these resources to support life far from Earth. Reflect on this curious fact. The gravitational pull of large planets can significantly influence asteroid orbits. This gravitational tug-of-war, known as orbital resonance, can alter an asteroid's path, sometimes sending it hurtling into the inner solar system or ejecting it into the interstellar void. It's a dynamic dance governed by the invisible threads of gravity shaping the destiny of these spacefaring rocks. There's also the intriguing possibility of asteroids being remnants of ancient cosmic catastrophes. Some asteroids might have originated from the debris of long-gone moons or planets, shattered by massive impacts. These fragments drift through space, silent witnesses to the violent events that once sculpted the solar system. Imagine harnessing the potential energy of asteroids. Some asteroids are thought to contain vast quantities of rare metals, such as platinum and gold. Mining these celestial treasures could revolutionize industries on Earth, providing resources that are becoming increasingly scarce. It's a tantalizing prospect, unlocking the riches of space to benefit humanity. Finally, consider the intricate processes involved in predicting asteroid impacts. Scientists track the orbits of thousands of asteroids using sophisticated models to forecast potential collisions with Earth. This proactive approach allows for early warnings and possible deflection strategies, ensuring that we are prepared for any threats from the cosmos. It's a testament to human ingenuity and our ability to adapt and safeguard our future. In this vast universe, asteroids remain enigmatic travelers, their stories intertwined with the history of planets and the potential for life itself. As we continue to explore and learn from these celestial bodies, we uncover the delicate balance between destruction and creation that defines our cosmic neighborhood. The more we understand, the better equipped we are to navigate the future, guided by the lessons etched in these stony relics of time. Let me invite you to imagine something extraordinary: asteroids carrying microbial life across the cosmos. While it might sound like science fiction, some scientists propose the idea of panspermia, where life might be seeded on planets via asteroids and comets. These celestial bodies could harbor hardy microorganisms, protected within their rocky shells, traveling vast distances until they find a hospitable environment. This fascinating concept stretches our understanding of life's potential pathways across the universe. Speaking of life's potentials, it's intriguing to note that some asteroids are not solitary wanderers. In fact, there are binary and even triple asteroid systems, where 2 or 3 asteroids orbit each other like celestial dance partners. These systems challenge our understanding of gravitational interactions in space and raise questions about their formation. How do such configurations arise? And what do they tell us about the chaotic processes of the early solar system? And here's something curious about asteroid material itself. Unlike Earth, most asteroids are not differentiated, meaning they have not undergone the process of separating into layers like crust, mantle, and core. This undifferentiated state offers a pristine glimpse into the materials that formed the planets billions of years ago, essentially providing untouched samples from the dawn of our solar system. Imagine holding a piece of an asteroid. It would be like holding a time capsule from the universe's early days. Now, consider this. While most asteroids reside in the asteroid belt between Mars and Jupiter, these near-Sun asteroids, known as volcanoids, are elusive and difficult to observe due to the Sun's intense glare. Discovering volcanoids would provide insights into the dynamics of close solar orbits and perhaps reveal new aspects of solar system evolution. Here's another thought-provoking fact. Some asteroids are not solid bodies, but rather piles of rubble loosely held together by gravity. Known as rubble pile asteroids, these objects are composed of multiple fragments that accumulated after a collision. Their porous structure can absorb impact energy, potentially making them more resilient to collisions than solid asteroids. These unique characteristics offer unexpected challenges and opportunities when considering them for mining or deflection. Let me share something surprising about asteroid colors. They can be quite varied, ranging from dark, carbon-rich surfaces to bright metallic reflections. These color differences are not just superficial, they reveal clues about the asteroid's composition and history. By studying their spectra, Scientists can infer the presence of minerals, metals, and even water ice, painting a detailed picture of these ancient travelers. As we delve deeper, consider the mysterious Trojans, asteroids that share an orbit with a planet, like Jupiter's Trojans. These asteroids are trapped in stable regions, leading or trailing the planet. It's a cosmic balancing act maintained by the gravitational forces of the planet and the Sun. Studying these celestial hitchhikers could unlock secrets about planetary formation and migration, offering a glimpse into the early solar system's dynamics. And did you know that some asteroids have been found to contain water? The presence of hydrated minerals suggests that water ice, or even liquid water, might have existed in these bodies at some point. This discovery challenges previous assumptions that asteroids were dry and barren, opening up possibilities for their role in delivering water to early Earth and other planets. Here's a fascinating tidbit. Asteroids are not immune to weathering even in space. Cosmic rays, solar wind, and micrometeorite impacts gradually alter their surfaces, a process known as space weathering. Over millions of years, these tiny interactions can change the color and reflectivity of an asteroid, providing insights into its age and the environment it has traveled through. Moving on to asteroid impacts, did you ever consider how they might influence the course of evolution? The famous Chicxulub impact, which is believed to have led to the extinction of the dinosaurs, illustrates how a single event can reshape life on Earth. Such impacts create opportunities for new species to rise as ecosystems adapt and evolve in the aftermath. It's a reminder of how intertwined our planet's life story is with cosmic events. Here's something truly exciting. Technologies developed for asteroid exploration are finding applications on Earth. Instruments designed to analyze asteroid compositions are being adapted for use in mining and environmental monitoring. It's a testament to how space exploration can drive technological advancements that benefit our daily lives, bridging the gap between the cosmos and our home planet. Lastly, think about the potential for asteroid capture missions. Some scientists are exploring the idea of redirecting small asteroids into stable Earth orbits. These captured asteroids could serve as accessible sources of minerals and water, creating opportunities for research and resource utilization in a more controlled environment. It's a bold vision that combines space exploration with practical benefits for humanity. As you drift into a peaceful slumber, let these cosmic stories swirl in your imagination. From asteroids carrying life across the universe to their transformative impacts on Earth, each fact reveals a facet of the universe's grand tapestry, woven with threads of mystery, discovery, and wonder. Asteroids, those silent voyagers of the cosmos, continue to surprise us with their secrets. Did you know that some asteroids are surprisingly small? In fact, the tiniest of them are mere meters across, yet they still hold immense scientific interest. Despite their size, these miniature worlds can provide valuable clues about the building blocks of our solar system. Imagine tracking a pebble in the vastness of space, and how those small bodies could potentially rain meteorites upon our planet, leaving a mark that tells a tale of cosmic wanderings. Speaking of wanderings, here's something you might find intriguing. There are asteroids known as rogue asteroids that have been ejected from the asteroid belt. These renegade objects have taken a different path, often crossing the orbits of planets and potentially venturing out to the distant reaches of space. Their journeys can be unpredictable, and tracking their trajectories helps us understand the dynamic nature of our solar system. Just think about the mysteries these solitary travelers might hold as they drift far from their birthplace. Did you ever wonder how asteroids maintain their shape? Interestingly, this often depends on their size and composition. Larger asteroids tend to be more spherical due to their gravity pulling them into a uniform shape. In contrast, smaller asteroids can have irregular forms, sometimes resembling potatoes or even dog bones. These quirky shapes are a result of their composition and history, offering a visual record of the collisions and forces they have encountered over billions of years. Their appearance is like a cosmic sculpture carved by the hands of time itself. Here's another fascinating tidbit. Some asteroids spin so rapidly that they reach the verge of tearing themselves apart. These fast-spinning asteroids complete a rotation in just a couple of hours, and the forces at play are immense. It's like a cosmic dance where the music is playing just a bit too fast, yet somehow everything holds together. Understanding these rapid rotations sheds light on the strength and cohesion of asteroid material, informing our models of how these bodies might respond to external forces. Have you ever heard of the Yarkovsky effect? It turns out that sunlight can actually alter an asteroid's orbit over time. As an asteroid absorbs sunlight and re-emits it as heat, the tiny push from this thermal radiation can gradually change its trajectory. This subtle but significant effect has to be factored into calculations when predicting an asteroid's future path, adding another layer of complexity to the dance of celestial mechanics. Now, consider this. Some asteroids have their own magnetic fields. These fields are not as strong as Earth's, but are nonetheless fascinating, as they might hint at past magnetic activity or ion content within the asteroid. Studying these magnetic properties can reveal insights into the asteroid's formation history and the conditions in the early solar system. It's like reading a magnetic fingerprint that tells a story billions of years old. A particularly interesting aspect of asteroids is their potential as space habitats. The concept of hollowing out an asteroid to create a habitat for humans might sound like science fiction, yet it's being seriously considered as a way to support long-term space exploration. The asteroid's structure could provide natural shielding from cosmic radiation, making it a potential haven for future astronauts venturing into deep space. And here's something else to ponder. Some asteroids are believed to have organic molecules on their surfaces. The presence of such molecules, the building blocks of life as we know it, raises intriguing questions about the role asteroids might have played in life's origins on Earth. If these organic compounds were delivered to our planet through asteroid impacts, they could have contributed to the primordial soup from which life emerged. Did you know that asteroid impacts have the power to create precious gemstones? When an asteroid strikes Earth, the immense heat and pressure can transform carbon into diamonds. These impact diamonds are often microscopic, scattered across the impact site, but they are a testament to the incredible forces unleashed during such collisions. Imagine a cosmic alchemy, where the violence of impact brings forth a gem of exquisite beauty. Let's also consider the role of asteroids in scientific curiosity and exploration. The prospect of anchoring a spacecraft to an asteroid, studying it up close, and maybe even bringing samples back to Earth is a thrilling frontier. Such missions, like those undertaken by NASA's OSIRIS-REx or Japan's Hayabusa, they offer a glimpse into the processes that shaped our planetary neighborhood. Finally, think about the concept of asteroid mining. It might not be purely a pursuit of resources, but a step towards sustainable space exploration. By using the materials found on asteroids, future missions could reduce the dependency on supplies from Earth. This idea of harnessing celestial resources could transform how we approach long-term missions to Mars and beyond, making space exploration more feasible and less costly. These asteroid facts, each a thread in the rich tapestry of our universe, invite us to ponder the wonders and mysteries that these celestial bodies hold. They remind us of the interconnectedness of all things, from the smallest pebble in space to the grandest cosmic events. As you let these stories of asteroids and impacts accompany you into dreams, may they inspire a sense of wonder and curiosity about the vast universe we inhabit. Reflecting on the mysteries of asteroids, let's wander further into the realm of these intriguing space travelers. Picture this. Some asteroids are actually binary systems. This means they consist of two bodies orbiting each other, like a celestial dance of partners in the vastness of space. Such binary asteroids offer valuable insights into gravitational interactions and the dynamics of smaller bodies in our solar system. Interestingly, some of these systems even have moons of their own, creating a miniature solar system of sorts. Did you know that certain asteroids are classified as rubble piles? These are not solid monolithic objects, but rather loose collections of rock and dust held together by gravity. It's a fascinating thought, isn't it? These porous structures are a testament to the gentle gravitational forces that can shape even the smallest objects in the universe. Studying these rubble piles helps scientists understand the internal composition and stability of asteroids, shedding light on the processes of accretion and formation. Here's a captivating thought. Some asteroids have been found to contain water in space, locked within minerals, or as ice hidden beneath the surface, raises intriguing possibilities for future space missions. This water could potentially be harnessed as a resource for sustaining human life. Imagine the potential of turning asteroids into cosmic gas stations, supporting humanity's journey deeper into space. Another interesting aspect is the presence of asteroid families. When a larger asteroid experiences a collision, it can break apart, forming a family of smaller asteroids with similar orbits and compositions. These families offer a snapshot of past collisions and the history of our solar system. They are like cosmic genealogies, tracing back the lineage of these rocky bodies through time. Now, consider the idea that some asteroids might have rings. Much like the rings of Saturn, certain asteroids are thought to possess small, faint rings of debris orbiting around them. These rings, although not visible to the naked eye, are a fascinating feature that challenges our understanding of how rings form around smaller bodies. What about the notion that some asteroids are transient visitors from beyond our solar system? Occasionally, objects from interstellar space enter our solar system, offering a rare glimpse into materials and conditions from other star systems. These interstellar visitors, like the enigmatic Oumuamua, spark curiosity and wonder about the vast reaches of our galaxy and the possibility of other worlds. Here's another thought-provoking fact. The surfaces of asteroids can be surprisingly diverse. They are not just barren, rocky landscapes. Some asteroids are covered in a layer of fine dust, while others have smooth, bare surfaces with visible craters. This diversity reflects the varied history of impacts and weathering processes on these bodies, painting a complex picture of their evolution. Yes, like comets, some asteroids can develop tails. This phenomenon usually occurs when an asteroid's orbit takes it close to the Sun, causing volatile materials to vaporize and create a tail of gas and dust. These active asteroids blur the lines between asteroids and comets, offering a unique perspective on the behavior of small bodies in our solar system. Speaking of their dynamic nature, some asteroids change their brightness as they rotate. This fluctuation in brightness, known as light curves, provides clues about an asteroid's shape, rotation speed, and surface properties. By studying these variations astronomers can infer detailed characteristics of asteroids from millions of kilometers away. Did you know that certain asteroids could be metallic? These metallic asteroids are rich in nickel and iron, remnants of the cores of ancient planetesimals. Such metal-rich bodies are like treasure troves in space, holding valuable resources that could one day be mined for use in space exploration and technology. And here's an intriguing speculation. It's possible that asteroids played a role in Earth's geological history. Some scientists believe that asteroid impacts might have influenced the movement of tectonic plates, contributing to the dynamic processes that shape our planet's surface. The idea that celestial forces could have a hand in sculpting Earth's geology is a testament to the interconnectedness of cosmic and terrestrial phenomena. Lastly, let's ponder the legacy of cosmic impacts. While these events can be catastrophic, they also play a crucial role in the long-term evolution of planets and moons. Impacts can create craters, stimulate volcanic activity, and even contribute to the formation of atmospheres. They are agents of change, driving the geological and atmospheric development of celestial bodies across the universe. As we drift through these celestial wonders, imagine the vast tapestry of space, woven with stories of asteroids and impacts, each one a chapter of our cosmic history. These fascinating facts remind us of the dynamic and ever-changing nature of the universe, inviting us to explore, learn, and dream about the mysteries that await beyond our earthly bounds. Let me share something interesting about the role asteroids might have played in the origins of life on Earth. Some scientists theorize that these rocky visitors could have delivered essential organic compounds like amino acids to our planet. It's a wonderful thought, isn't it, that the building blocks of life might have a celestial origin, hitching a ride on asteroids that journeyed through space to reach our young Earth. Now, consider the remarkable fact that there are more asteroids in our solar system than stars in the Milky Way. With hundreds of thousands of them residing primarily in the asteroid belt between Mars and Jupiter, these space rocks far outnumber the visible stars in our night sky. It's a humbling realization of just how teeming and populated our cosmic neighborhood truly is. Speaking of the asteroid belt, did you know that it wasn't always there? Scientists believe that it might have been formed from the remnants of a failed planet that never quite came together in the early days of our solar system. This area, brimming with asteroids of all shapes and sizes, is like a planetary graveyard, telling tales of a past that never fully materialized. Here's another fascinating tidbit. Some asteroids have extraordinarily long orbits that take them far beyond the asteroid belt. These asteroids, known as Trojans, share their orbits with larger planets like Jupiter and Neptune. They are like celestial companions, traveling alongside these giants in a vast cosmic waltz, yet maintaining their distinct paths through the solar system. Imagine this. The surface temperature of asteroids can vary dramatically. Some can get as cold as -200 degrees Celsius in the shadowed regions, while sunlit areas might reach over 300 degrees Celsius. The stark contrast in temperatures is due to their lack of atmosphere, which means they can't retain heat in the way Earth does, leading to an extreme environment where temperature swings are the norm. Speaking of extremes, certain asteroids are not as solid as they seem. Did you know that some of them are actually so loosely bound that a human could theoretically dig through them with ease? These fragile structures are held together by the gentlest of gravitational forces, making them akin to cosmic sandcastles floating in the void of space. And here's a curious fact. Some asteroids spin so rapidly that they're almost on the verge of breaking apart. These fast-spinning asteroids, known as tumbling asteroids, rotate chaotically, creating a dizzying dance in the cosmos. Scientists study these objects to better understand the forces at play and how such rapid rotation can affect the stability of these rocky bodies. Let's talk about the potential of asteroids as time capsules. Because they have remained relatively unchanged over billions of years, they hold clues about the conditions in the early solar system. By studying these ancient relics, scientists can uncover secrets about the processes that led to the formation of planets, including our own. Here's something quite enchanting: the possibility of life existing on asteroids themselves, albeit not as we know it. Some researchers speculate that microbial life could potentially survive on certain asteroids, nestled within crevices or beneath their surfaces, protected from the harshness of space. Could these rocky wanderers be harboring tiny life forms quietly orbiting the Sun? Consider the idea that asteroids might influence other celestial bodies in subtle ways. For example, through gravitational interactions, they can affect the orbits of nearby comets or impact the formation of rings around planets. These interactions, though often unseen, play a part in the intricate dance of celestial mechanics that governs our solar system. And did you know that asteroids can serve as natural laboratories for testing scientific theories? By observing their behavior and characteristics, scientists can test hypotheses about gravitational dynamics, material properties, and even the potential for asteroid mining. These space rocks offer a unique opportunity to conduct experiments on a grand scale. Speaking of mining, the notion of extracting resources from asteroids is not just science fiction. In the future, humanity might harness the wealth of materials locked within these celestial bodies. Metals, water, and other resources could be key to sustaining long-term space exploration and supporting colonies beyond Earth. Lastly, let us ponder the notion that cosmic impacts, while often associated with destruction, are also catalysts for new beginnings. Impact events can create new habitats, influence evolution, and even lead to the creation of new elements through the intense heat and pressure they generate. These events, both feared and revered, are reminders of the cyclical nature of the universe, where endings often herald new beginnings. As we drift towards the end of our cosmic journey through the realm of asteroids and impacts, it's clear that these celestial wonders hold countless secrets and stories. They remind us of the interconnectedness of all things and the infinite possibilities that await our discovery. Each asteroid, each impact, is a thread in the boundless tapestry of the universe, inviting us to continue exploring, learning, and dreaming about the mysteries that lie beyond our view. Imagine, if you will, the incredible notion that some asteroids are composed almost entirely of metal. These metallic asteroids are thought to be remnants of the cores of ancient protoplanets that were shattered in the tumultuous early days of our solar system. Like cosmic relics, they carry within them the stories of celestial collisions and transformations that shaped the planets we see today. Speaking of transformations, did you know that a single asteroid impact can alter an entire planetary atmosphere? When a sizable asteroid strikes a planet, it can release enough energy to propel dust and gases high into the atmosphere, potentially triggering climate changes that can last for decades or even centuries. Now, consider this. The asteroid that famously led to the extinction of the dinosaurs was not the largest impact Earth has experienced. There are craters on our planet much older and even larger, like the Vredefort crater in South Africa, which spans a mind-boggling 300 kilometers in diameter. It serves as a monumental reminder of the colossal forces that have shaped our world over billions of years. Speaking of shaping worlds, did you ever wonder how astronomers can determine the age of an asteroid? It's done by counting the number of craters on its surface. The more craters an asteroid has, the older it is likely to be. Each crater is a testament to the countless collisions it has experienced, marking the passage of time on these ancient travelers. Here's something that might surprise you. Not all asteroids reside within our solar system. Interstellar asteroids, like the famous Oumuamua, occasionally visit from other star systems, offering a rare glimpse into the materials and conditions of distant corners of the galaxy. These cosmic visitors may hold clues about planetary formation processes that differ from those in our own solar neighborhood. And here's another intriguing thought. Some scientists believe that asteroids could be used as stepping stones for deep space exploration. By establishing bases on these bodies, future explorers could use them as waypoints, refueling stations, or even habitats on their journeys to distant worlds. Have you ever considered the role of asteroids in Earth's water supply? It's thought that water-rich asteroids, known as carbonaceous chondrites, may have delivered much of the water that filled our oceans. These hydrated minerals could have been the source of the life-giving liquid that covers over 70% of our planet's surface today. And speaking of life, here's a whimsical idea. Asteroids have been proposed as possible arks for humanity's future survival. In scenarios where Earth becomes uninhabitable, these celestial bodies could serve as refuge ships, carrying humans and other life forms to safer havens in the cosmos. Did you know that asteroids can sometimes have their own moons? These miniature companions, known as satellite asteroids, orbit around their larger counterparts, creating a tiny solar system of their own. The dynamics between these pairs are fascinating to study, offering insights into gravitational interactions on a smaller scale. And while we're on the topic of companions, consider this. Some asteroid pairs are actually contact binaries, meaning they are two separate bodies that are gently touching. These precarious formations are the result of low-velocity collisions, where the gravitational pull between the two bodies is just enough to hold them together. Here's a delightful fact. Despite their rocky exteriors, some asteroids might contain vast reserves of organic molecules, including amino acids, the building blocks of life. These molecules could have been delivered to Earth by ancient asteroid impacts, seeding our planet with the ingredients necessary for life to flourish. It's a cosmic recipe that might have been repeated on countless other worlds throughout the universe. Imagine the variety of life that could emerge from such celestial cooking. Now, let us ponder the immense speeds at which asteroids travel through space. Some can move at velocities exceeding 30 kilometers per second. At such speeds, a journey from Earth to the Moon would take less than half an hour. These rapid rocketing journeys through space make asteroids both fascinating to study and challenging to track. And speaking of challenges, predicting the trajectory of an asteroid is a complex task. Gravitational influences from planets and other asteroids, known as the Yarkovsky effect, can cause their paths to shift unpredictably over time. This effect occurs when an asteroid absorbs sunlight and re-emits it as heat, creating a tiny but consistent force. Finally, consider the cultural impact that asteroids have had on humanity. Throughout history, they have been seen as omens, heralds of change, and symbols of both destruction and creation. From ancient myths to modern science fiction, asteroids have captured our imagination, challenging us to look skyward and ponder our place in the universe. Their stories, both real and imagined, continue to inspire generations to explore the mysteries of the cosmos and dream of the possibilities that lie beyond the stars. As we drift further into contemplation, the wonders of asteroids and cosmic impacts remind us of the dynamic and ever-changing nature of the universe, inviting us to keep exploring and embracing the unknown, one celestial whisper at a time. Have you ever considered the unique colors of asteroids? These space rocks don't just come in shades of gray. Some asteroids reflect unexpected hues due to their mineral compositions. For instance, certain iron-rich asteroids can have a reddish tint, while others might shine with a blue or greenish glow. These colors provide valuable clues about their composition and history, allowing scientists to piece together the processes that have shaped them over billions of years. Here's something you might find intriguing. Certain asteroids have been identified as rubble piles. These are not solid chunks of rock, but rather loose collections of boulders held together by gravity. Scientists believe these asteroids formed from the debris of larger bodies that broke apart, then slowly reassembled over time. This fascinating structure can make predicting their behavior an exciting challenge for astronomers. Did you know that some asteroids are actually metallic? These rocky remnants of planetary formation are rich in metals like nickel and iron, making them incredibly dense. In fact, one such asteroid named Psyche is believed to be composed almost entirely of metal, offering a tantalizing target for future exploration. Imagine the potential for mining these spaceborne metal reserves, a concept that has already captured the imagination of space entrepreneurs. Speaking of exploration, did you know that asteroids could be used as cosmic laboratories? Their varied compositions provide a natural archive of the solar system's history. By studying these ancient travelers, scientists hope to unlock secrets about the early solar system and the processes that led to the formation of planets and moons. Here's a whimsical thought: some asteroids even have tails. Although we often associate tails with comets, certain asteroids exhibit this feature as well. Known as active asteroids, these objects can release dust and gas, creating a tail that stretches behind them. This phenomenon is often triggered by collisions or rapid rotation that exposes volatile materials. And here's another captivating fact: the surface of some asteroids is surprisingly young. Despite existing for billions of years, certain asteroids have surfaces that appear much younger due to constant resurfacing from small impacts and space weathering. This ongoing transformation erases older features, giving these ancient bodies a fresh appearance. Imagine this: a single asteroid impact can generate enough heat to liquefy rock. The intense energy released during a collision can create vast pools of molten rock called impact melt, which eventually cool and solidify into new geological formations. These features are visible in large impact craters on Earth and other planetary bodies, offering a glimpse into the violent forces that have shaped our solar system. Did you know that some asteroids share orbits with planets? Known as Trojan asteroids, these celestial companions are found in stable Lagrange points, trailing or leading a planet along its orbital path. Jupiter hosts the largest population of Trojans, but Earth and other planets also have these intriguing neighbors. Their unique orbits and interactions provide valuable insights into the gravitational dynamics of our solar system. Here's a delightful tidbit: some asteroids are shaped like space potatoes. Their irregular, elongated shapes result from their varied formation histories and the gravitational influences they experience. These odd shapes often make them look like oversized tubers floating through the cosmos, adding a touch of whimsy to their celestial journeys. And speaking of shapes, have you heard about the asteroid Bennu? This near-Earth asteroid is known for its spinning top shape, with a distinctive ridge around its equator. Scientists believe this shape results from rapid rotation, causing material to migrate toward the equator and accumulate over time. Bennu's intriguing form makes it a prime target for research missions aiming to understand asteroid formation and behavior. Consider this: asteroid impacts have played a crucial role in shaping Earth's biological history. Beyond the extinction of the dinosaurs, these cosmic collisions have influenced the evolution of life by periodically resetting the ecological stage. Each impact-driven mass extinction event creates opportunities for new species to emerge and thrive, demonstrating the interconnectedness of cosmic and biological evolution. Here's a thought-provoking idea. Some asteroids are considered time capsules. These ancient relics have remained largely unchanged since their formation, preserving the primordial materials from which the solar system was born. By studying these pristine fragments, scientists hope to uncover insights into the chemical building blocks that formed planets and gave rise to life. And did you know that the study of asteroids has inspired new technologies? The challenge of tracking and mitigating potential asteroid impacts has led to advances in space observation techniques, propulsion systems, and even planetary defense strategies. These innovations not only protect our planet, but also drive technological progress that can be applied to other areas of exploration and industry. Lastly, let's ponder the idea that asteroids have been silent witnesses to the solar system's history. As they journey through space, these celestial travelers carry with them the echoes of past events, from the births of stars to the formation of planets. Each asteroid tells a story, written in its composition, shape, and orbit, inviting us to listen and learn from the ancient whispers of the cosmos. In this vast and ever-changing universe, asteroids remind us of the delicate dance of cosmic forces and the endless possibilities that await our discovery.